Welcome back. How'd you go drawing those Lewis structures, those extra problems I left you in the additional resources area? Hope they all went to plan. Today we're going to try drawing some more Lewis structures to represent our covalent compounds, but this time we're going to look at structures that do involve double and triple bonds. So once again, I've got your rules up on screen here, just as a reminder. So these are the 6 steps that we'll be going through in order to draw our Lewis structures, but this time we will be invoking that 6th step. We will be having a look at double and triple bonds. So let's launch straight into our first example. Our first example is going to be formaldehyde. It's a nice small molecule for us to work on. You may have heard of formaldehyde before. You find it in biology labs. It's that liquid that they store awful looking biological specimens in to preserve them, prevent them from going off. That's the stuff that they've used in the past. So let's draw our formaldehyde. Just like before, we start by drawing our skeleton of the structure. So once again, least electronegative element goes in the middle. In this case, that will be the carbon. It's less electronegative than oxygen. So carbon in the middle, and the other 3 atoms around it, like so. The next step is to count the number of valence electrons that we have available to us. So we go back to our periodic table. Hydrogen is in group 1, so that's 1 valence electron, and there are 2 of them. Carbon is in group 4, that's 4 valence electrons. Oxygen is in group 6, that's 6 valence electrons. Add them up, and we've got 12 electrons in total that should be in our final Lewis structure. Let's move on now to the 3rd step. We're now putting single bonds between all of the outside atoms and the central atom. So just connecting the 2 hydrogens and the oxygen to the carbon with single bonds. Following that, we then make octets with our lone pair electrons. We want to make sure that every atom has its octet, that it's happy, that it's stable, content. So we do our counts, we check round. Remember, hydrogen, one of those small exceptions, it only wants 2 valence electrons, only wants that single bond, so don't worry about them, they're fine. We look at the carbon in the middle, it can see 2, 4, 6 valence electrons, so it needs 1 lone pair, another 2 electrons to be able to see 8. The oxygen over on the right can only see these 2 valence electrons, so it needs another 6 valence electrons. Everyone's got their stable octet? Everyone looks happy? Right, time to do our count. Check how many valence electrons we've used in making this structure. I have 2, 4, 6, 8, 10, 12, 14 valence electrons in my structure. So, when we compare our check with the original count we had, we can see that they don't match. That tells me that this is not the correct Lewis structure. But as I mentioned in the last topic, what I love about this system, even when you're wrong, you're still right. It tells you immediately how to fix it. For every 2 electrons your count is over that limit, you need 1 extra bond. We're 2 electrons over that total, so that means we need to introduce 1 double bond somewhere into this structure. So if we go back and have a look at our structure, we can see the hydrogens over here, they only ever want 1 bond. They're not going to be interested in double or triple bonds, so we can ignore these 2 places, which means we've really only got 1 option. We need to add an extra bond between the carbon and the oxygen, like so. So we've got a double bond. You'll notice now that we have overloaded the carbon and the oxygen. They've both got too many electrons. So clearly we made a mistake earlier when we were filling out our octets. So we get out an eraser and we remove a pair from either end of our double bond. If you check now, the carbon atom can see 2, 4, 6, 8, so it's happy, and the oxygen can see 2, 4, 6, 8. It's happy. They're both happy. This should be our Lewis structure. Good practice, do a final check. Make sure your totals now add up. In this structure we're using 2, 4, 6, 8, 10, 12 valence electrons, and that matches the original count that we had. So this is our Lewis structure for formaldehyde. Once again, you can see an artistic impression there, proving that this is indeed the correct structure for you. Seem okay? Let's try another example together. Here I have acetylene. Acetylene is the fuel they use in oxy torches for welding, so it burns with oxygen to create a very hot flame. May have seen that before. Once again, by drawing the skeleton, the least electronegative, the carbons are going to go in the middle, so I'm going to place my 2 carbons side by side, and I'll put the hydrogens out on either end, like so, the outside. We then, like always, count up the number of valence electrons that we have available to us. Hydrogen is in group 1, and there are 2 of them. Carbon is in group 4, so 4 valence electrons, and there are 2 of them. 4 times 2 is 8, plus another 2, we have 10 valence electrons in this structure. So now, time to join up our atoms with single bonds. So a single bond between the hydrogen and carbon, the 2 carbons, and the other hydrogen and carbon, like so, all done. After that, we make octets with lone pairs, make sure everyone can see their 8 valence electrons. Once again, don't worry about the hydrogens, they're fine. It's the 2 carbons we're worried about. So this carbon here can see 2 4 valence electrons. This one here can also see 2 4 valence electrons, so they each need another 4, another 2 lone pairs. There we are. Once again, everyone's got their octet, everyone looks happy. Time to do our check, time to make sure we're using the correct number of valence electrons. So I have 2, 4, 6, 8, 10, looks like trouble already. 12, 14 valence electrons in this structure. So, quite clearly we've gone over that limit, but once again remember, for every 2 electrons you are over that limit, you need 1 extra bond. We are 4 electrons over that limit, and that means we need 2 extra bonds in our structure. So, let's have a look at our options. Once again, I can't place one between the hydrogen and carbon because hydrogen never wants more than 1 bond. Same thing down this end, can't do that. So there's only one place for these extra bonds to go. It's got to be between the 2 carbons. So I need to put 1, 2 extra bonds between the 2 carbons. I've created a triple bond in between those 2 carbon. Once again, they've now got far too many electrons. So when I count it up, carbon has 2, 4, 6, 8, 10, 12. It doesn't need either of those lone pairs of electrons. So I'll remove those. And the other carbon is in exactly the same situation. If we do a quick check again now, you can see that this carbon can see 2, 4, 6, 8, and the other one can see 2, 4, 6, 8. So they're both happy. Once again, do that final check to make sure you haven't slipped on the way. This structure now has 2, 4, 6, 8, 10 valence electrons, and that is exactly what we wanted. So this would be the Lewis structure for acetylene. Once again, artist's impression showing that, yep, we've got this perfectly right. So now that we have all these skills for drawing Lewis structures, you should be able to draw them to represent all kinds of simple covalent compounds and even some more slightly challenging ones. Once again, I've placed a few extra examples in the additional resources area for you because practice makes perfect. Give them a go, make sure you're up to scratch with them. In our next topic, we'll talk briefly about how we can then use these skills to create very large covalent compounds. See you there.